For this lesson, we're going to be looking at intercepts. And intercepts are important points on a graph. The y-intercept, also called the vertical intercept, is where the graph intersects the y-axis. There's your y-axis, and so where your graph intersects the y-axis, that is the y-intercept. The x-intercept is where the graph, or the horizontal intercept, is where a graph intersects the x-axis. So this is the x-axis, where the graph intersects it is the x-intercept. So let's look at a few examples. We're going to identify the vertical, or the y, and the horizontal, or the x, intercepts. So for graph A, your y-intercept is here, and it has a value of 75. Whereas the x-intercept here has a value of 25. Now you can write the intercepts as just their x and y values, as I've done, or you can also write them as an ordered pair. Remember, when you write ordered pairs, you write the x value first and then the y value. So for a y-intercept, your x value is 0. The y value in this case is 75. For the x-intercept, you could write that as an x value of 25, whereas your y value is 0. For graph B, y-intercept is right there. So we can say the y-intercept equals 600, or we can write that as an ordered pair, 0, 600. The x-intercept, where you intersect the x-axis, right there, that's 10, 11, 12. So the x-intercept has a value of 12, or as an ordered pair, you would write that as 12, 0. Okay, for the next example, we're going to look particularly at the y-intercept. And we have a function, f of x equals negative a half x plus 2. And that graph is shown to you in part B of the question. So we're asked in part A to determine f of 0, or what is the function's value when the input, or the x value, is 0. Well, we know how to do this. We just substitute 0 wherever we see x. So f of 0 equals negative 1/2 times 0 plus 2. Negative 1/2 times 0 is just 0, plus 2 equals 2. So the f at 0 equals 2. Where is that point on the graph? Right here. So we can see that the y-intercept occurs when the x value is 0. The y-intercept occurs when the x value equals 0. Or you can say the x value of the y-intercept is 0. Let's do the same for the x-intercept. We have the same function, f of x equals negative a half x plus 2, and now what we're going to do is determine the input x when the function's value is 0. We know how to do this. Set the function's value to 0 and solve for x. So we have 1/2 x plus 2. This is our starting equation. We want to get x by itself, so we'll subtract 2 from both sides of the equation. So on the left side, we're going to have 0 minus 2, which is a negative 2. On the right side, the plus 2 and minus 2 cancel each other out, and we'll have a negative 1/2 x. Okay, so at that point, to get x by itself, we'll have to multiply by negative 2 over 1, multiplied by negative 2, or negative 2 over 1, it's the same thing. And we'll do that on both sides and see what our result is. Negative 2 times negative 2 on the left is 4. And then negative a half x times negative 2, you'll see the 2 on the top and bottom cancel out. The negative times negative is positive, that cancels out. So we have 4 equals x, or x equals 4. Same thing. Where's that point on the graph? Right there, on the x-intercept. So we can say, whereas in the y-intercept, that occurs when the x value is 0, we can say the x-intercept occurs when the y value equals 0. Or you can say the y value of the x-intercept equals 0. Okay, so let's determine the x and y intercepts of each equation or each function. So we'll do x-intercepts on the left and y-intercepts on the right. We'll start with the y-intercepts because generally they're easier. Remember that y-intercept is when x equals 0. So all we'll have to do is figure out the y value when the x value is 0. So y in this case equals 0 plus 7, so y equals 7. So your y-intercept is y equals 7, or as an ordered pair, you can say that it is 0, 7. Both are correct. As far as the x-intercept, that is when y equals 0. So here you have to set the equation equal to 0. 0 equals 4x plus 7, and solve that equation for x. Okay, so if that's your starting point, you can subtract 7 from both sides. On the left-hand side, you'll have negative 7. On the right-hand side, 4x. And then we can divide each side by 4 to get the x by itself. And our result on the right is 4 divided by 4 is just x. And the fraction we have left is 7 over 4. So that is the x-intercept. As an ordered pair, that would be 7 over 4 and a y value of 0. For the next equation, again, we'll do x-intercept on the left, y-intercept on the right. Reminder, the y-intercept occurs when x equals 0. The x-intercept occurs when y equals 0. Let's start with the y-intercept again. Here we'll have 4x, the x value is 0, so 4 times 0 minus 2y plus 16 equals 0. What we want to do, we're solving for the y-intercept, so we want to solve for y, or get y by itself. After the 4 times 0, that's just 0, and we have a minus 2y plus 16 equals 0. To go about solving this for y, we can add 2y to both sides. And what you'll see, if we're starting here, what you'll see as a result is on the left-hand side, minus 2y plus 2y is 0. So on the left-hand side, you're left with just plus 16. And on the right-hand side, you have 0 plus 2y, which is just 2y. And now to isolate for y, we'll just divide each side by 2. So we'll have y equals 8. Y equals 8, or you can also write this as an x value of 0, a y value of 8. Same thing. For the x-intercept, that occurs when the y value is 0. So here we'll solve for x after we make the y value 0. So we'll have 4x minus 0 plus 16 equals 0. So what we want to solve for x is 4x plus 16 equals 0. Okay, at this point, to isolate for x, we want to subtract 16 from both sides and see what our result is. So on the left-hand side, we'll have 4x, because plus 16 and minus 16 is 0, or it cancels out. 0 minus 16 on the right is just a minus 16. So at this point, we can divide both sides by 4, and we'll have an answer of x equals negative 16 over 4, which is negative 4. As an ordered pair, that would be an x value negative 4, a y value of 0. Next couple of examples, same sort of thing. We'll solve for x-intercepts and y-intercepts. Let's do the y first. Again, the y-intercept happens when x equals 0. So we'll take our function, f of x or y, and that equals negative 5 times 0 minus 2. So y equals 0 minus 2, or y equals negative 2. Your y-intercept is y equals negative 2, or as an ordered pair, that is 0, negative 2. As far as the x-intercept, you want to set your y value as 0, because the x-intercept happens when y equals 0. So we have 0 equals negative 5x minus 2, and we're going to solve for x. To get x by itself, first we'll need to add 2 to both sides. On the left-hand side, we'll have 0 plus 2 is 2. On the right-hand side, the negative 2 plus 2 is 0. It goes away, and you're left with negative 5x. So to get x by itself, we'll divide both sides by negative 5. And you'll be left with x equals negative 2 over 5. So that is your x-intercept. As an ordered pair, you can write that as negative 2 over 5 with a y value 0. Next example, same thing. If we want the x and y-intercepts, and we'll start with the y-intercept. Again, we'll take a look at the y value when x is 0. So just substitute 0 in for any x you see, and solve for y. So we have here 0 minus 3y minus 4 equals 0. We want to solve for y, so we should add negative 3y to both sides. And I'll show you why I'm doing this. Because if I do this, on the left-hand side, you'll see negative 3y plus 3y just goes away. And on the left-hand side, we're left with a minus 4. And on the right side of the equation, I have 0 plus 3y, which is 3y. Now I can divide both sides by 3. And I'll have y equals negative 4 over 3. That's my y-intercept. You can write it as an ordered pair. I'm just going to leave it like that for now. Or why not? As an ordered pair, this is 0, negative 4 over 3. Okay, as far as the x-intercept, that occurs when the y value is 0, and then we solve for x. So 2x minus 3 times 0 minus 4 equals 0. So the equation we're solving is 2x minus 4 equals 0. And we want to get x by itself, so we'll add 4 to both sides. And we'll have 2x equals 4. At this point, we can divide both sides by 2. And we'll have 2 divided by 2 is 1 times x equals 4 divided by 2, which is 2. So our x-intercept is 2. As an ordered pair, that would be 2 with a y value of 0. And we can even use x and y intercepts to graph a linear function. This word linear function means your functions will be straight lines. So we're going to sketch the value of this linear function by graphing the x and y intercepts. So if we're given that function f of x equals 2x plus 3, first step is find your x and y intercepts. Let's start with the y. The y-intercept, we know that happens when x equals 0. So that's y equals 2 times, let's write this more clearly, 2 times 0 plus 3. So that is y equals 3. Y equals 3, or as an ordered pair, 0, 3 is your y-intercept. Let's look at the x-intercept. X-intercept we know happens when the y value is 0. So we'll have 0 equals 2x plus 3. And we'll subtract 3 from both sides. So we can solve for the x value. We'll have minus 3 on the left. On the right-hand side of the equals, we'll have 2x. So next step would be dividing both sides by 2. And we'll have 2 divided by 2 on the right is just 1 times x. And on the left, you just have negative 3 over 2. So your x-intercept is negative 3 over 2 as an ordered pair, negative 3 over 2, and 0. So let's first graph the x and y intercepts. Negative 3 over 2 is a negative 1.5. So on the x side, if this is negative 1, this is negative 2, negative 1.5 is somewhere in between. That's our x-intercept. The y-intercept is on the y-axis, and it has a value of 3. So 1, 2, 3 up. That is the y-intercept. If we're graphing a straight line, all we need to do is connect those two dots. And we can extend it even. So our line would look like this. So we have the x and y intercept, and we just draw a line through those two dots, and that is the graph of our function. And on to the last example. We have another function, and again, we want to graph it by finding the x and y intercepts. So y-intercept happens when x is 0. So we'll solve for the y, and we'll substitute each x with a 0. So we'll have y equals 0 plus 6, or just y equals 6. That's our y-intercept. For the x-intercept, that occurs when y is 0. So we'll set the y value to 0, or the output value to 0, and we'll solve for x. So here we can either subtract 6 from both sides, or we can add 3x to both sides. I'm going to add 3x to both sides because in general, when I have a variable, I like to deal with a positive coefficient. That's just me. If you want to subtract 6 from both sides, you can do it that way as well. So we'll go plus 3x on both sides. And I'll have 0 plus 3x on the left. That's a 3x. The negative 3x plus 3x goes away on the right, but I'm left with a plus 6. And now you'll see I have a positive 3x on the left. I can just divide both sides by 3, and I'll end up with x equals 2. So y-intercept is 6, x-intercept is 2. Y-intercept is on the y-axis, it has a value of 6. X-intercept is on the x-axis, it has a value of 2. We have those 2 points. We just connect those dots and extend them. That is our linear function, or our straight line. So I'll post the worksheet online if you guys can do that. And let me know if you have any questions either by email or come to those online tutorials Tuesdays and Thursdays, 1 p.m. Thanks.